Okay, so welcome to this week of engineering graphics. So this week we're going through M5. So what is M5? M5 is technically taking a 3D model, right, and unraveling it, as you can see from the first slide. So what you do, for example, you have a cube. The cube is made of 6 sides. So you flip it open. Similar to a pyramid, cone, and cylinder. Okay. So prism or cylinder, you can use a very simple method. It's called paraline method. You just unravel it along the long part. Yeah, I would say the long part, which you can see up here by the red lines, and you just unravel it. Prisms or cylinders are very easy to unroll. So you can see here for a right angle prism, just different faces. For oblique square prism, first, some surfaces, as you can see, are diamond shapes, and some surfaces are squares. For example, this surface behind here. So you form into a shape sort of like this. Okay. So now, you don't expect your M5 bit to be that easy. So you're normally dealing with more difficult shapes. So one of the ways to overcome that is something called surface development or the triangulation method. So what is the triangulation method? It's splitting up surfaces into many smaller surfaces and working on it one by one. Okay. So as you know from your I think M3, right? How to determine the true length of a line? Well, true length of a line, you need to reflect it along a reference line. Then you get true length here. So similar to this, these two are true lengths. No, actually this is everything here is true length. Yes, everything here is true length. So yeah. 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 If you look from the bottom, right, every single one of these surfaces are true lengths. This is a hexagon and all the hexagons are the same length. So AF, FE, ED, DC, CD, DA are all the same length. But because it's cut at I would say 45-degree angle, right? Some of them, well, the vertical distance between each line is the same, but the line connecting them are different due to the cut. Later I'll teach you how to figure out how long the cuts are and how to do it. Okay. So how to determine true length? You flip it along axis. So with your protractor, right? When you have a true length, then you can bring it down and you can find another true length. Then this. I'll share the slides later. So when you have the slides, if you're not clear on some of them, you can ask me. What is it? Determine the true length of point C. So C. Okay. They will be more useful when you have doing the question itself. Okay. I'm gonna ask, what's the link again? You invite them. Okay. Okay, so for example, I know you're doing your M3 now, so you probably refer to this in the future. So yeah, so TP project a point that is not true to its true length to obtain its true distance. So what the hell does that mean? Okay, so imagine you have a shape like um, okay, imagine you have a shape like this. Ignore these parts first. Ignore these parts first. So imagine a shape like this. What it essentially is, if you look at it from a larger scale, is technically a pyramid. Yeah. So you can open a pyramid up. And to find true lengths, okay, actually, so for now, skip a few slides. Okay, never mind. I'll go straight into doing the question. So, okay, I'll be doing question 5. Okay, question. So let's start with question 5. Clear this. This. Can you see the paper? Or the do you see anything on the paper? Hello?
Can see, but
Can,
it's the angle is a bit. It's horizontal.
oh, so okay.
Yeah, I think it's vertical. Sorry.
Okay. Is it fixed now?
Yeah. Can.
Okay. So I'll be going through M5 question 5. So for starters, I'll show you what it looks like first. So once you're done with M5 question 5, right, it will look sort of like this. Yeah. Yeah, it looks sort of like this. Okay. So, okay. So normally what you do first, you start by doing this view and this view. So you copy whatever you see on the paper. So that's the first step. So after doing the first step, right, which is very sometimes quite hard, then you do the actual I say development. You deskin the pyramid or the shape. So you open it up. So you start with this first. So sometimes this is very not hard, not easy. So let's get started. Okay. So first up, uh, start with an empty piece of paper. Uh, if you refer to your M5 question 5, right, you see that the bottom shape has a lot more um dimensions compared to the top shape. So accordingly, you should be you should tell yourself, oh, is that so? So you start with the bottom shape first because it has more dimensions. You can't really draw something with not a lot of dimensions. So I'm gonna start from the bottom. So starting from the bottom. Then so starting from the bottom, just draw a line first. Lines. Just
建议 I don't think there's any sound output.
Can you hear me now?
Yeah, I can hear you.
Wait, how long have I been muted?
I think for 5 minutes or something. I was wondering how come, like, I thought you were like just drawing out the basic shape first, then.
Oh no, I was talking. Okay. Thank you for telling. Holy shit. I think something went wrong. Okay, never mind. So anything from this you don't understand? Like I drew this already. This is at this is 30 degrees. And this is 30 degrees. So you can use a trusty set square as this side is 30 degrees. So you can use it to draw. And this will be the final shape. Okay. Can? Okay, can. So okay. Now for the top. Okay. Before I do that, let me draw a few lines and I'll explain them later. So you see this BD, right? I'll take the BD, draw a line across. So it's vertical height, I draw a line across. 2 and 4, I will draw a line across. These points will play a part later. Okay. So, but first, let me project points 1, A, C upwards onto this shape. Because you use those points above too. Okay. So, project up. Okay, then project A up. Then project 1 up. Okay. So now, see, A is somewhere, no, 1 is somewhere here. Then A is here. So if you look from the top, A and 1 are straight lines. So I will darken this later. Then this part, this point is 3. Okay. This now the question is, right? Wait, oh, then this point is C. Okay. Now the hard part. Where is 2? Where is 4? Where is B? Where is D? There's nothing to reference from. Okay, so for that, right? Okay. You see the lines, this horizontal lines I drew. So what you're supposed to do with this is you take your compass, you measure 2, 4, measure the horizontal line to here. Okay. 2, 4, horizontal line to here. Okay. Okay, 2, 4. So you take 2, 4, and you can mark it here, mark it here. Now this will be your 2. This will be your 4. Okay, I'll now explain why. Okay. So let's just say you imagine that it's not oblique. Let's just say that it doesn't have this weird outhang below. Imagine it's a flat pyramid. Okay. Imagine it's a flat pyramid, right? So if you look from the top, right? Flat pyramid. So when you take this length, right, and you push it up all the way, it will be around here. So how to say? Okay, yeah. If this was flat, entirely flat, a flat pyramid, the corners, this one will go all the way up. This one will go all the way up. This one you'll project it up. But now it doesn't exist, so you project it up. It'll be around here, here, and here. Then you'll imagine, like if I cut out the bottom. So once I cut out the bottom, right, the distance between 2, 4 and this, I'll just call it 3 prime. Then imagine there's a 3 prime here. Okay, 3 prime. So the distance from the center, okay, let me draw it as a circle. It should be easier to visualize. 3 prime. Okay, guys, see this circle I drew. So if this didn't cut off here, right, this will be a point. This 3 prime here will be a point. And 3 point to the center distance will be equivalent to center to 2. Because a pyramid is kind of like a square, then you keep cutting at intersections. So 3 to center point, I'll call center point O, right? So 3 to origin is the same as 2 to origin. So you can draw a circle, and that's where you can find where your point 2 is. It's a bit, I say, you need to kind of imagine like, cutting it off. But once you get it, it's like 3, 2, 1, 4 are all, wait, 1 is not on the line because it's a bit higher. But if there was a 1 prime will be here. Okay. So let me fill in the shape that you get for the number portions. So 2, 3, 8, and 4, 4, 3, connected to 1, 1 to 2. Okay. Now just in the meantime connect 1 to 8. Okay. Now you do the same thing with BD. See BD and it sticks out to C. So you take BD, right? Then you use your compass, find where's C. Okay, I found C. Okay, not C, but C prime. Okay, you take your compass, and you can use it to mark this here. I won't draw the full circle because it will get kind of messy. But then get D is on top, D is below. Then I can proceed to connect dots. Okay. 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 So this is what the shape looks like. Let me connect all the other dots together. 2 to B, 3 to 4, C to 3, and yeah. So the two views will look like this. And now you know a very important skill. There'll be a lot of triangles for the development. So when you have a triangle and you have like a 30-degree cut or 45-degree cut, right? Link it to the edge of the thing, like here. So if you look from this side, right? This line here, this line here, this line here, this entire line is a true length. So true lengths are very important. So yeah, true lengths when you project it to a true length, this part you can bring it up and draw a circle. So you can find the distance between O and B. A. Okay. You use it a lot more in the future. Okay. So now for the next step. Okay. So for the next step, honestly, okay. So for the next step, I'll just start from okay. I'll use this half of the paper. Okay, so draw one line across. Then one line vertical. Oh yeah, if I go silent for more than 10 seconds, like half a minute, right? Just tell me in case something will go wrong again. So okay, draw a vertical line down. Vertical line. Okay. So okay, vertical line down. So what's the next part? So the next part is this thing. So as you know, um it is a pyramid shape. So for a pyramid shape, right, you can flip it open. So flip, flip, flip. So I say so pyramid. So you can take V to I'm not sure if you can see this, but V to X. Then this is V to X. The point C will be on this point. Okay. So basically what you want to do, right, is take every major point that is on a true length, like C, A, 1 and 3, and you just draw it completely. Draw it through all the way. Advice is at least 180, because sometimes it's more than 180, but for this question, it only reaches up to 180 degrees. So right now, what I'm gonna do is take set square, no, compass. Okay, measure the distance from the apex of the pyramid to the bottom. Three. Okay. And from this point I marked out, I will project it up all the way. Stop. Then then um no. So take it as it is. This is 90. The height 90. Then the next part is the tip of it to A. And measure it up. Draw. I need to draw this longer. Okay. Now one, not I. Then you can draw the B and D. So for B and D, right, you can't just do this because it's not a true length. So remember what I said about true lengths? You always project it across, then you take the one that is the true length. So for B and D, you take this length, the horizontal. So I'll just label this B prime. Yeah, B prime. Uh, wait. Shit. C line, this is the B line, the A line is I line, and now for the 2 and 4 line. So for the 2 and 4 line, so for the 2 and 4 line, I do the same thing. Project line horizontally to a true length. So then true length, you measure from the apex to the true length. Okay. Now let's start. So as mentioned in the question, the seam is at A1 and the seam is hinged at AB. Bottom is hinged at 1, 2. Okay, don't care about the hinges first. We'll go to the reflections, the each surface first. So for the first line, right? Actually, let me just label. This is C, this is B, D, this is A, this is I, this is 2-4, and this is 3. Okay. So for the first, if you start from the seam, right? You start from A and I. So for A and I, okay. So this is our seam, AI. Okay. Now for the next step, 1. Okay. 2. Okay. Now the question is, where is 2? Okay. So for 2, okay. Thing is, you don't know where 2 is, but okay. Label. I shall make some more labels. There'll be a lot of labeling for this. So I'll label the bottom on the right side of the triangle as X, top as Y, bottom is Z, the imaginary pyramid that we built. So the imaginary pyramid will be Y and Z. Okay. So what is the distance between Y and Z true? Like, okay, no, X and Y true. So this length is true length. Like, okay, it may be a bit confusing. Imaginary true length, but it's let me just draw. Okay. So let's say you don't have this shape. You have a pyramid, 4-sided pyramid. Base is each side is 60 with a height of 90. If you open up that pyramid, the bottom of each side will still be 60. So here to here, the straight line distance is 60. So yeah, but I'm not finding the straight line. I want to see how far the faces are from each other. So X to Y. And if I draw it out using a constriction line, pretend that this surface, everything in this pyramid is in here. Yeah, this pyramid is equivalent to this pyramid, which is this pyramid is equivalent to the pyramid that is behind this surface. So yeah, the same pyramid. Okay, so now on this origin to y, what is the thing you have to care about? You have to care about 2 and b. So 2 and b are respectively here and here. So b and minus 2, 2 is here. Second last line. Okay, so push it now. Some of the tutors would want you to label the thing. So do label. So this is b, this is 2. Okay. Now, knowing this first step, what you can do now is you can just finish finding all the sides. So each side is 60, right? Okay, 60. I'll just mark from here. I mark here. Mark here. 60. Oh no. Ran out of space. It'll be kinda here. Yes. Shit, ran out of space. Oh, not again. Never mind. Right, 2 up. Okay. Right. Okay. Never mind. Yeah. I'll draw a few more first. Okay. So this is y is 3. So 3 will be here. So I can just draw it first. Notice how fast it is after you just finish a few. So B connects to C. Where is C? C is here. Okay, C is here. Then D will be, okay, let's not complete that first. No, he can. Okay. D will be here. Oh no. Wrongly. Space. Okay, this is not 3. See wrongly. Erase it. This is 3. Yeah. Okay. Here to here. Okay. Still safe, I guess. Process through the same line. So B will match up with C, and C will go to D. D is here. Okay. Don't worry, it might look like a straight line, but kind of does. Now, this 3 will connect to 4. 4 is here. Okay. 4 is here. Now for the next one. Okay. Okay. I think I drew it too high, but should be around here. So for a real one, do draw it lower. Don't draw from, take from this line, take from this line. So the next ones are A and I. Okay. Okay, so connect it together. A and I. Yay, okay. So this shape opened up. It should look symmetrical because these two faces are the same as these two faces. So it looks symmetrical. Okay, so what is the next step, you may ask? So for the next step, you have to draw the covers, the different covers. So there'll be the cover at the top, A, B, C, D, and the cover at the bottom. 1, 2, 3, 4. Okay, so how to do the cover? So for the cover, normally what you want to do is split it into, okay, as you can know, the cover is a diamond shape, right? So for the diamond shape, ideally what you want to do is to split in half. So it becomes two triangles. Because two triangles, right, are easier to work with. Okay. Okay. So for the two triangles, what thing you take? So for starters, okay. So since you slice it directly here, the distance of okay, then if you look at this from the bottom, or yeah, if you look at this from the bottom at this angle, what it's gonna look like? It's gonna look like a triangle here, right? And 1, 3, and 4, 2. So what I want is the distance between this on this length. So this length, right? 1 to 3. So you take your compass, measure 1 to 3. Okay. Then after you measure 1 to 3, you mark it here. Okay. This will be the bound of the line. Okay. So now 1 to 3. What is the next thing we're gonna copy? To 3. Okay. Give me a sec. Okay. So what is the distance of 2 to 3? Well, the distance of 2 to 3, right, is actually this distance here. Because since it's a cover, it should cover 1, 2, 3, 4, right? So 1 to 3, 2 to 3. Yeah. So if it was cover, it'd be 1, 2, 3, 4, 1. Yeah, 1, 2, 3, 4, 1. So the cover with the same the 2 to 3 of the cover will be 2 to 3 of this as well. So you can use this to measure. So what we'll do now is take the ruler and you can mark your tree. So this will be your tree. Okay. Likewise, you can do that for the other side as well. But realize you don't have a 2, right? But you have these two starting points and the lengths of 2 to 3, 3 to 4, and 4 to 1. So what you can do is you take compass, right? you just mark here. Then you get 1 to 2. I'm doing this only because it's a diamond. So how to say? It will 1 to 2 has the same as 1 to 4. So this intersection will be 4. Okay, so cancel 1 to 4. Therefore, 3. Okay, and that will be your bottom cover. Well, magic. Okay. Do label your points. Yeah, it will be helpful for you. Okay. 1, 2, 3, 4. So that is the bottom cover. Now we move to the top cover. So you basically do the same thing. Yeah. How monotonous. So you measure A to C. So A to C, right? Then take compass and let's mark somewhere here. Okay. A to C. Now BC. Take this. Measure. Okay. This will be the point. And connect it first. Okay. So BC. This will be C. Okay. So now same thing. BC. Same length. Keep draw along. Then you take measure AB again. Okay, AB. Okay, mark. C here. Here. Go to here. Then yay, done. So A, B, C, D. And this will be the final shape. Actually, I'll refer you to this. This is more cleaner. Yes. I don't go out of the papers. Stop a bit. Okay. Can screenshot if you want. Okay. Okay, I shall. Actually, I won't go through the second question because it'll really take too long. So in the meantime, right, I'll just do section A first. So I can comfortably say, right, if you can get these steps down for like if you can do question 5, you practically can do question 4, 3, 2, and 1. Because question 5 has like everything covered. And I would say question 1 and 2, right, are very simple. Your prof might not even give them because it's really too simple. Yeah. Because you're just flipping it open and it's horizontally. While this is a pyramid. So this is a very high level already. So if you can do this, right, you should be able to do the rest. So for the remainder of time, right, I'll just do a Q&A. So if you have any questions, you can ask me. So if you don't have any questions, then I guess we can end it here. Okay then. See y'all next week, and yeah, I hope to see more of you here. But I think next week most of you have tests, so yeah. Okay, stop recording.
Wait. Can I ask? Can I ask something?
Sure.
Can I ask? Just now the basic shape, right? Can you show how to get the top one?
Oh, the top one.
Yeah.
Okay. It's similar to the bottom. So okay, what you want to do, right? If you look at 1, 2, 3, 4, like remember auxiliary, if you look at it from this angle, you'll see this triangle thingy, right?
Yeah.
Okay. And if you look at it directly head on, it will be like a true shape kind of thing.
Oh,
right?
okay. Yeah.
So what is the distance from 1 to 3? It's a true shape. So if you can get 1, 3, which is a true shape, and you plot it here, right?
Yeah.
Then all you need is take 2 and oh shit, went through the paper. Yeah, 2 and 3, right? Distance between 2 and 3, and you mark it out too. So you find out the point of 2 to 3. Just imagine this shape, right? So one, can you see this? It's a bit small, but 1 to 3 will be the bottom of the thing. Then 2 to 3, they can find out point 3. That's how you do it. You basically split it into 2 triangles. Then you solve half a triangle at a time.
Oh,
Yeah.
okay.
That's how you do the top and bottom. For squares, it's a lot easier lah. Like squares, you just squares. But for this is the harder one. So I go through the harder ones because the harder questions have all the basics inside. So if you can do this, you should be able to do the rest already. Yeah.
Okay, can. Thank you.
Any other question? Okay, if no other questions, stop recording.